So in this lecture, we're going to talk about descriptive statistics. So to give you a quick overview, I'll describe what descriptive statistics are, and then we'll spend some time talking about ways in which we can organize data. We'll talk about measures of central tendency, and then measures of variability. So statistics is the science of organizing, describing data, as well as making inferences based upon the data that you analyze. And there are two broad types of statistics: descriptive statistics, which we'll talk about today, which deals with organizing and summarizing data, and then inferential statistics, which involves trying to make conclusions about a population based upon the data that you obtain from a sample. So let's spend some time talking about descriptive statistics. And I want to focus on frequency distributions and different types of graphs. So imagine that you were teaching a class and you had 50 students in the class, and you had each student take a 100-item exam. Now, if you put all this information into a spreadsheet, you would end up having 5,000 unique pieces of data. So one piece of data per item per student. How could you try to organize and summarize this data so it's not so hard to make sense of? So 5,000 pieces of data in a data set is really hard to kind of organize and summarize. So what can you do to make that process a little bit easier for you so you can make sense of how your students did? Well, you might try to simplify it by finding a way to summarize it. And there are a few different approaches that we can use to try to summarize that data. So one is a frequency distribution, and then some visual ways of looking at a frequency distribution are bar graphs and histograms. So a frequency distribution is when you arrange a set of scores from lowest to highest, and then you indicate the number of times each of those scores were present in your data set. So you'd have typically 2 to 3 columns. You'd have a column for the actual scores, which for this example we'll call X. You'll have a column for how frequently those scores were in the data set, which is typically signified by a lowercase f. And then occasionally you'll see where there's a third column, which is the percentage of people who scored that particular score in the data set. So here's an example of a frequency distribution based upon students' grades in this class for exam number 1 last semester or last summer. As you can see, the possible outcomes are A, B, C, and D. There's no F's. And so in the data set, we had 6 A's, 2 B's, 2 C's, and 3 D's. So all you're trying to indicate here is how frequently those particular outcomes occurred in the data set. So pause the video for a moment, and what I want you to do is I want you to try to create a frequency distribution based upon these different religious groups. So again, you're going to want a column for the different religious groups, and then another column for how frequently they occurred in this particular data set. So pause the video for a moment and create that distribution. Now, hopefully that's something like this. So you should have 3 Catholics, 6 Protestants, 3 Muslims, 4 Buddhists, and 4 atheists, right? And I won't actually do this on an exam or on a paper, but you could also indicate the percentages. Now, a bar graph is a representation of a frequency distribution based upon categorical data. So like categories like race, year in school, political ideology, major, right? And each bar represents a unique category of scores. And the higher the bar means that the more frequently that particular category occurred in the data set. And importantly for categorical data, when you have a bar graph, you want to have spaces in between your categories. And you'll see this when I give you an example in a second. So here's a bar graph for the data that I reported a few minutes ago for students' grades in the first part of exam one, right? So as you can see here, we have a bar indicating that there were 6 A's, 8 B's, 5 C's, and 1 D. And again, there's a space between the bar because these are distinct categories. When it's continuous data, you don't have bars in between the different spaces in between the different bars. But for categorical data, you do. So now I create a bar graph based upon this data that we had for the different religious groups. So pause the video and create a bar graph to represent this information, this data set. Now it should look something like this. So again, you have 3 Catholics, 6 Protestants, 3 Muslims, 4 Buddhists, and 4 atheists. And again, you can see there's spaces between the different categories because this is categorical data. Now a histogram is a graphic representation of a frequency distribution based on continuous data, right? So you can think of like the amount of time that elapses, or scores on an exam, age. These are all continuous variables. And because they're continuous variables, there's no spaces between the different categories. And again, that tells the reader that you're dealing with continuous data and not categorical data. So here's a histogram of the grades that we talked about from last semester. As you can see, we have one person who scored about like a 22. Then we had a number of people scoring in the 30s, a few people scoring in the 40s, and then some more who scored in the 50s. And just recognize that there are gaps here in this distribution, this histogram, because there were people who didn't score within those particular ranges. So, for example, nobody scored a 25, so there's no bar there for 25. It's basically indicating that no one scored that particular value. All right, so now that we talked about ways in which you can organize data with frequency distributions, bar graphs, histograms, now let's talk about ways in which you can summarize data. So let's first talk about central tendency. And this is the number that best represents a distribution of scores. So if you have some data, it's the one score that can best summarize or characterize that particular data. And there are 3 primary measures of central tendency: the mean, the median, and the mode. And this should all be reviewed from stats classes you're taking. The mean, as I'm sure you're aware, is the average value of a distribution of scores. Like for averages, you sum up all the scores and divide it by the total number of scores. So pause the video for a second and then calculate the mean for this distribution of scores. Again, all you're doing is you're adding up the scores and then you're dividing it by the total number of scores. Now, to kind of illustrate the limitations of the mean, what I want you to do is I want you to imagine that I am an employer and I'm looking for someone to work at my research lab, and I tell you that the mean income for the 5 people who presently work in my lab as research assistants, the same position that you'll be applying for, is $100,000 a year. Given that information, would you be interested in taking the job? Now, hopefully you recognize that this might be a little bit problematic, right? Because it's saying the average income is $100,000. That does not necessarily mean that everybody has $100,000. So what could be a situation is that maybe of my 5 employees, 4 of them make $25,000 a year, and the 5th person, let's say, who might be my mom, right? I pay her $400,000 a year. Now, if you average it out, it equals $100,000. But as you can see, this distribution of scores is really skewed, such that that $400,000 income is making the overall mean of income for this distribution to be higher than it really is in real life. In reality, Most scores are more along the $25,000 range, not the $400,000 range. So now you're probably thinking, oh, the job is not that enticing because most likely you'd be making 25,000, not 400,000. So what that does is it helps to demonstrate the limitations of the mean. The mean works perfectly when you have a normal distribution of scores, right? So we know we'll talk about a normal distribution in a couple classes, but it has this nice bell-shaped curve to it. When you have a distribution like this, the mean is a great representation of the distribution of those scores. But when your distribution is skewed, right? So now it's not a nice normal distribution. It's skewed either positively, right, where most people are on the lower end and a few people are on the high end, or if it's skewed negatively, where most people are on the high end and a few people on the lower end, then the mean is a relatively poor measure of central tendency. So when you have a skewed distribution, either positive or negatively skewed, you're going to want to use the median instead of the mode. The median is the score that divides the distribution in half. So half the scores are going to be above the median, half are going to be below the median. So a simple way to calculate the median is when you put all your scores in order from lowest to highest, and then get the middle number. Um, when the middle number is even, you take the average of the two middle scores, and that would be your mean. When it's odd, you just take the middle number. So now at the bottom here, what I want you to do is take a moment, pause the video, and calculate the median for this set of scores at the bottom. The mode is the least frequently used measure of central tendency because it only factors in essentially one score, and it is the value that occurs most frequently in your distribution, right? So it's only really like whichever one occurs the most, that is the mode. Now there are some contexts where you might have something that's multimodal, where you might have more than one mode. So maybe the number 10 or the value 10 shows up, the same number of times as the number 5, and those are both the highest occurring score. So those would be called, if it's two of them, it's bimodal. If there's three of them, it's trimodal. But again, this is a poor measure of central tendency because it only takes into account one value. So if I have 1,000 scores, it really only takes into account one value from that set of 1,000 scores. So it's probably not the most representative of all the scores in the distribution. So what I want you to do for a moment, I want you to pause the video, and I want you to calculate the mean, the median, and the mode for these three samples. I want you to write them down, and I want you to take a minute and look at the differences between the means, the median, and the modes for these samples. So if you did this exercise, what I want you to think about is how do these different samples differ from each other? Like they had a lot of similarities, but there was some very important differences. So the mean, the median, and the mode were all pretty much the same, but as you hopefully noticed that the distribution of scores were not the same. They all had the same mean, median, and mode, but there were some very important differences. And the differences are that the scores around the mean, median, and mode vary dramatically between the three different sets of scores. And so what we're missing when we're looking at only central tendency is we're missing the importance of variability. So that's looking at how the scores are dispersed around whatever measure of central tendency that you're using, right? Are they really close to around that central tendency measure, or are they more spread out, right? The more variability, the more spread out they are, right? The smaller the variability, that means that the scores are much more closely centered around that measure. And there are three measures that we typically use for variability: the range, standard deviation, and variance.